19 million fixed rate mortgages, originated between January 1, 1991 and June 30, 2015. However, we decided to take a sample of 50,000 loans from a particular origination cohort, so in 2007. So we are 2007. Using data that was riddled with error could give us a seriously detrimental impact on our analysis. So we decided to remove some observation from our dataset that appeared to have been coded incorrectly, or they missed for some important values in the observations. So in order to understand what will come in the next slides, I would like to do a brief introduction. So let's imagine the professor comes to us asking for a loan of $1,000. So we are at time t, and professor comes to us. At time t, we have the origination data. So we have, what is the origination data? It is the set of all the information that professor gives us when he asks for the loan. How does it work in reality? In reality, we are considering just two times, a range of time between t and t minus k. So we, throughout the observation we have to decide if we give money to the professor or not. We try to match the information the professor gave us with the information, similar information of an historical borrower, in order to predict a model which goes from time t to time t plus k, which is able to tell us if the professor will default or not. In our construction of the model, it works in a different way, because we don't consider the range of time between t and t minus k, but we just consider this range of time. So we have to construct a model, but why we can do it? Because we have not the information at the end. But in reality we have, because we have the other set of data, so the performance data, that at time t plus k tell us if the professor has defaulted, if the professor has not defaulted, but tell us also the behavior of the professor during the time, so also the frequency of payments of the professor. So as I say, we have two sets of data. The origination data for summarizing everything. The origination data tell us, okay, the information are good, you should give money to the professor, because the information, it could be a good client. After that, we construct a model which predicts the probability of the default of the professor during this time. And at time t plus k, the performance data will tell us, oh, you did wrong. You had not to give money to the professor, or you did good. So talking about the origination data, so information at time t. I will talk about the variables we used for the construction of the model. So I will not go deeper on the first payment day, maturity day. But I would like to talk about the credit score. Well, as you can see, the credit score is just a number. But it's a big number, because it's a number prepared by third parties, which let you understanding the client credit worthiness, so the capability of the capacity of the client to pay his obligations. After that, we used a lot the LTV, and as you can see, there is also the LTV, the combined LTV, and the DTI. The LTV, it's quite easy, because it's a ratio between the loan the professor has and the appraised value of the property. So let's suppose the professor asks for a loan of $100,000 for having a property of $200,000. The LTV will be the ratio between $100,000 and $200,000. Which is the difference? What is the difference between LTV and LTV combined? LTV combined consider more than one loan for the same property. So if the professor asks $100 from one loan and $50 from one loan, the ratio, the combined LTV, would be loan 1 plus loan 2 over the appraised value of the property. And the DTI, it's also quite important because it's also a ratio, but between the monthly debt of the professor over the monthly income of the professor. Let's go ahead. After we can find the rate, the maturity date, the first payment date, we can go to the next slide. The next slide, so we are at time t plus k. We know the behavior of the professor during this time with the performance data that we have. The loan sequence number, what is the loan sequence number in our analysis? Is a number associated to each client. So it will be different from each client from another. And the default is our dependent variable, as I say, the binary variable. And it will associate the number 0 if the person does not default. So if he pays regularly his obligation. And the number 1 if the person has defaulted during that time. And the loan grid, as I said before, we know everything about the professor. We know if he has paid, the frequency of payments. So here we can find a letter like C, L, but also number 1, 2, 3. What do they mean? The C letter is it means that the professor pay regularly his obligation, so he's okay. The letter L means that the professor obtained refinancing in order to pay the loan. So we can find, after the first L, we always find all the other L, because the professor refinanced himself in order to pay his obligation. And after that, we can find also the number. The numbers represent the status of delinquency. So remember, as I said before, defaulted is considered a person after a status of delinquency of 60 days. So the number 1, we will find the number 1 after a status of delinquency between 30 and 59 days. So it's okay. The number 2 is from 60 to 89 days of delinquency. So you are defaulted after number 2, and this way also number 3, number 4, number 6. So we can have a look. After number 2, you have always the number 1. So you are always defaulted. So okay, you can go to the next slide. Last thing to say, talking about the data set, is how did we cover the missing data? For covering them, we followed three different steps. The first one, firstly, we thought to cover this missing data using the average of all the regressors. So creating this model, covering the missing data with the average of all the regressors. But we understood that it was a bad model, so the output was a bad model. After that, okay, so we changed our mind, and the second step was looking also at some graph like this, and some table to represent this missing data as approximately a normal distribution. We can see, looking at the skewness and the kurtosis, that a normal distribution has to be a skewness equal to 0 and a kurtosis equal to 3. And the mean has to be equal to the median. In this model is approximately a normal distribution, so we thought to represent this missing data with approximately normal distribution adjusted for kurtosis and skewness using their mid polynomials. But it was a bad model too. So we changed again our mind and we cut this data. In particular, we delayed the loan sequence number of the client who missed for some important variables, like I said before, credit score, LTV. We delayed this. And this situation led us to have a good level of K-Smirnov test, which is the test which tells us, okay, you did a good model, okay, you didn't have a good model. So it's a test which tests the efficiency of the model we created. After explaining the data set,